Good day, I am Stephen Gabriel as Alojado from MEXE 4102, a mechatronics engineering student from Batangas State University. And today, we're going to be discussing sorting by height basic in factory I/O. So first thing to do is to open our factory I/O application, then go to the scenes tab, and we can see here the sorting by height basic scene. So for my case, I've already saved a scene that I used in programming this process. So the objective of this scene is to sort card boxes by their heights using a chain transfer system. So let me run you through the components inside this scene. First is the control panel. We have here 3 push buttons. First is the start push button. Start push button is used to initialize the process, while the stop push button is used to stop the process and reset the logic in our PLC program. Next is the reset button. The reset button is used to reset the counter, and the counter is a display that is used to display how many boxes have already passed the left and right conveyors. And the selector switch is a selector switch used for switching 2 modes, the manual and the automatic mode. Now, let's identify the actuators and the sensors inside this factory I/O scene. First, we have the entry conveyor, which is responsible for loading our boxes towards the chain transfer system. And here at the entry of the chain transfer system, we have sensors. First is the pallet sensor, which detects that there is a load at the entry of the chain transfer system, and the low sensor is used for the small boxes, while the high sensor is used for detecting large boxes. We have here the left conveyor. As for the left conveyor, we have 2 sensors, the at left entry sensor and at left exit sensor. The entry sensor is responsible for turning on the conveyor and also turning off the chain transfer left when the box already passed through this sensor. As for the exit, we are going to use it for turning off this left conveyor when the box already passed through that sensor. Also, it creates an increment to our counter when the box already passed through that sensor. The process is identical to the right side. So we also have here at right entry sensor and at right exit sensor. Same process is applicable with this right conveyor. Since we have already identified the components here at this factory I/O scene, let's visualize the process through a flowchart. We have here 3 processes: the start, process A, and process B. Start mainly deals with our control panel and the process A for the left transfer system and the process B for the right transfer system. So let's first look upon this start process. So first, it will wait if the automatic selector switch is on, and if yes, it will, and the start push button is pressed, it will make the start light on and also turn on our entry conveyor. Then it waits for the low sensor or the high sensor that detects a signal. If a low sensor detects a signal, it will be fed to the process A, and if the high sensor detects a signal, it will be fed to the process B. Same goes with the manual operation, but there's a discrepancy or difference here at the process A and the process B. As for the stop push button, if it's pressed, start light will be turned off and the stop light will be on, or the red light will be on, and it also turns off all actuators and reset the logic of our PLC program. So if it's not pressed, it will wait for other push buttons or other processes to be initialized. For the reset push button, if it's pressed, we all know it will only reset our counter. So let's tackle about the process A. Process A is a sequence of processes or sequence of events that happens when a box is being transferred to the left, while the process B is a sequence of processes that is present when it's being transferred to the right. So these two will be identical, just the direction of the transfer process. So let's discuss this briefly. When a pallet sensor detects a signal, it will wait if the chain transfer actuator is running. If it's running, it will turn off the entry conveyor. If no, it will just return. Then next is, if the load sensor detects a load, it will turn on chain transfer left actuator. Then if the left entry sensor detects a load, the left conveyor will be turned on. And if it passes through the left entry and the automatic mode is on, it will turn on the entry conveyor. If it's not in automatic mode, meaning it's in manual mode, it will end the process. Then after it passes through this left entry sensor, it will turn off the chain transfer system. Then if the left exit detects the load, it has 2 functions: our left exit, turn off the left conveyor, and also increment our counter, then displaying it into our counter present in the control panel. The same process is applicable to the process B, just the direction of the process, which is towards the right. As for the program, I've used TIA Portal as my PLC programming environment. So we have here 19 networks. So let's run through the different networks that I use for this program. First is the start auto logic. It is responsible for initializing our automatic control bit. Then our start light, it is also responsible for initializing the start light or the green light in our control panel. So it initializes if the start bit is on and the manual bit is also on. Stop light, same way. if the start bit is not running or the manual bit is not running, the stop light should be on. As for the entry conveyor, the entry conveyor will turn on if we press the start push button. As you can see here in our start auto logic, it initializes the start push button, and down here at our start manual logic, it also initializes to the start push button. So the conveyor will be turned on if the start bit is on or the manual bit is on, and it latches. Then we use a stop push button to stop this actuator when the stop PB is pressed. As for the entry conveyor of conditions, so here are the conditions that are used to make the entry conveyor turn off. Here's the transfer left, and the pallet sensor detects a signal, and the transfer left is initialized, so it will turn off this entry conveyor. Same way to the right chain transfer system, and also the M1.1, which deals with the conveyor should stop after one box entry, so it's for the manual operation. So here in the loading process is responsible for the load actuator. So when the start bit is on or manual bit is on and the pallet sensor detects a signal, as long as the chain transfer left or right is not activated or there is no load in our chain transfer system, the load actuator will run. Then these are the logic for the small box. For the small box, so we use low sensor to detect. So we have here a normally closed high sensor because, as you can see here, if a large box is detected, as you can see here, when a large box is detected, it also initialize our low sensor. So for us to compensate with that, the high sensor should not be on when detecting a small box. So we put it here. Initially, it is put here, but I opted to do this so that when operating in high speed, it won't interfere on resetting this small box bit. As for the large box bit, same way, we just use the high sensor as our sensor that activates this bit. So we use memory bits for the PLC to remember the status or the box that have entered this. So we interlock these two boxes so that it won't interfere with each other when a process for this one is being initialized. Small box bit reset, so meaning it will be reset when the left entry has already passed through, or the right entry or the load has already passed through these entry sensors. And as for the left transfer process, it initializes the left chain transfer. If a small box bit is initialized and the pallets has already been loaded, it will be transferred to the left. Same way to the right transfer process, just for the large box bit. And the left conveyor process is done when the left entry detects a signal which initializes our left conveyor or the right conveyor if it's a large box. Then this M0.6 is used to reset or to turn off our conveyor to a exit sensor. So we use P3 since our sensor is normally close. We use P3, make the process only or make this bit initialize when the box already passed through that sensor. So we have here the counter. We use also the memories for the left exit bit for counting our boxes that pass through our process. So we have here the start manual logic. This is the conveyor stop conditions for the manual mode. So that's it for our PLC program. Since through the TIA portal, it is possible to switch the programming language to FBD. So for higher compatibility of my program towards the native PLC programming software, I converted this FBD in Control.io. So the same process is identical with the ladder logic that I've created. So here I've already separated it by processes. So it is easy to see which program is responsible for each process. Now let's go to the demo of our program. So let's go first to our driver. Then let's first test our TIA portal program, which is loaded to the PLC sim. So let's start, then reset our counter and reset all actuators and the logic. So first at manual mode, when we press this start push button, it will only transfer a single box. So in order to transfer again another box, we need to press the push button. There you go. So for loading our automatic, just tick this selector switch, then it will run in automatic mode. As you can see, our conveyors will only be actuated, the left and right conveyor only be actuated if there's a load inside. So it's for the power efficiency of our system. So let's now look upon our Control.io program, which is here. It is expected to run the same way. So let's reset, stop. And for the manual, it will only run once. And when we activate the automatic mode, it will automatically or run continuously. As you can see, we are operating in high-speed mode. So this is the normal speed of this process, but it is also capable of running in high speeds. So in a manufacturing environment, it is beneficial for us if we can run it in high speeds. So that's all for my PLC program of this factory IO scene. I hope you learned something from this. Thank you and bye.